All right, my students, here are the answers for the Chapter 20 review questions. Number one says, list some ways in which scientists get information about past changes in Earth's climate. So there's lots of evidence, that we can uncover. I mean, everything from like tree rings give us an idea of climate as we go back in time. Um, things like radioactive isotopes of rocks and fossils. But really a big one, as you can imagine, like right now, if we were to take a sample of air, we could do an analysis of that and figure out all kinds of stuff like the amount of carbon dioxide in that air, the amount of pollen, if there's any ash in it, things like that might indicate a forest fire, and all sorts of different things. Well, turns out, let me share this with you here. We can look at ice cores. So what they can do is core down, and as you can imagine, ice piles up right this way, right? So the deeper down we go, kind of like fossils, the farther back in time we're going, and there are air bubbles trapped in there, and we can do analysis of those and figure out things like what was the composition of the troposphere, meaning what percent was nitrogen, oxygen, carbon dioxide, and that sort of thing. And from that, we can just gather all kinds of information and determine pretty closely what the temperature and climate would have been like. And so that was it's one huge piece of information and way that we can figure out what the past was like. All right, number two, what is the Earth's natural greenhouse effect? All right, so first, we want to remember that we want a greenhouse effect to a point, right? If we did not have any greenhouse gases, the average temperature would be below freezing on this planet. So it's good that we have them, but I like to compare it to when you're sleeping in a blanket, right? Let's imagine it's wintertime or whatever, having a blanket's nice. A thin sheet might not be enough. Remember, it's your body heat that's actually wanting to escape. The heat doesn't come from the sheet itself. The sheet is actually trapping in some of your heat. But the question is, why is a sheet not enough? And the answer is, well, the sheet is keeping in some of the heat, but it's also letting a lot of the heat escape out into the room, and it's not keeping enough in. So you feel like you still feel cold, all right? Now, sort of the other extreme would be, imagine if you're sleeping and someone played a trick on you, right? And they put 6 sleeping bags on top of you. You know what would happen, right? You'd wake up, you'd be sweaty, like, wait, what's going on here, right? Remember, the sleeping bags are not the source of the heat. You are. What the sleeping bags are doing is they are trapping that heat in and not letting it escape, so you get warmer. So we'll say the perfect blanket for you, right, is the one that traps in the right amount of heat and also lets the right amount of heat escape. And so we have certain greenhouse gases like carbon dioxide and water that trap in some of the heat. And life has sort of evolved to certain temperatures. And since it is these greenhouse gases that trap in the heat in the atmosphere, as we have higher concentrations of those, the idea that then they would trap in more heat seems very reasonable. And the 4 major greenhouse gases, right? Water vapor, carbon dioxide, methane, and nitrous oxide. All right, so list some human activities that increase the input gases, greenhouse gases into the troposphere and could enhance the Earth's natural greenhouse effect. Essentially, when we burn stuff, all right? Especially fossil fuels. So when we are burning coal, remember, coal was buried under the ground, really never to sort of make its way back up if it weren't for us for digging it up. So coal, natural gas, crude oil, all these things are loaded with carbon and really supposed to be sort of in the ground really forever, but what we do is we bring it up to the surface and we burn them. So burning and these using of fossil fuels are really the major things that are putting these greenhouse gases back into the atmosphere. Okay, and then enhance the natural greenhouse effect and make it trap in even more heat. All right, number 4, list some signs that the troposphere is getting warmer. One second here. Okay. Well, a lot of it is if we're paying attention. Number 1, when we look at recorded data, temperature, we see this trend. We can plot it. We see that the average temperature is going up, especially this century, right? It seems to be one record year after the next as far as warmer temperatures. But also, if we look at things like the level of ice melt, we see that too. We see warming of the oceans. And so, putting all these things together, we see it really indicates to us that the troposphere, the atmosphere, and actually our oceans are also warming. 5, describe changes in the Earth's poles and in Greenland, Alaska that indicate the troposphere is warmed in recent decades. And essentially, we see not only is it getting warmer in these colder areas faster, sort of like the canary in the coal mine. So we're seeing change there happening more quickly, but also we're seeing huge amounts of ice melt, more than normal. And the question is, how do you hold that back? You can't put a rope around ice as it's melting to hold it back, right? So it just happens, right? And so we have large amounts of the ice melting, but also big chunks breaking off. And also one theory too, like we see in Greenland, are these fissures that, so if you could imagine you're actually on the glacier and these deep, fissures that go to deep down, and we can see water rushing down there. And what we're concerned about and what we think might be happening is that water, let's say, imagine the glacier's this high, right? But super high. The fissure goes down, the water hits the bottom and goes, as it's flowing underneath, it might be lubricating this, allowing bigger pieces of that ice to break off even more quickly. Okay. All right, 6, according to the latest models between the year 2000 and 2100, about how much increase is projected in for the global average temperature, anywhere from 2.5 to 5.5 degrees Celsius. And frankly, 2.5 isn't good and 5.5 is really bad. And so we want to try to do everything we can right now to try to minimize that. And at first you might say, well, that doesn't seem like that much, but it is, again, as a global average temperature, that is a significant change, causing lots of problems to a lot of species that not only have evolved under very specific conditions, but also it raises the good chance of a lot more unpredictability of the weather, not just global warming, but everything could be, some places could be warmer, some places could be colder, some places could be drier, some places could have even a lot more rain. And so it's just, and then again, as it changes, it's very difficult, if not impossible, for species to keep up with that change. All right, 7, what are the implications for humans if climate shifts rapidly within a few decades? And same kind of thing, it's very chaotic, to say the least. Not only, okay, we could look at food production. Plants have evolved to very specific conditions to where they are. And if things change quickly, one example, a cactus, right? It's evolved to be very drought resistant, and but other plants in the rainforest, right? They've evolved to have very big leaves, and actually they release a lot of water because it rains a lot, right? So they can do that. But if things change too quickly, the species just, and then we're talking about animals too, and humans, would be very difficult to try to keep up with those changes, not only to agriculture. One other thing too, right, is warmer water often leads to more intense storms and more rainfall in certain areas, which rain is one of those things that you want in the right amount. You don't want too little, but of course a flood can be very damaging too. So you want the right amount. So not only that unpredictability for agriculture, but also rising sea levels too. We have a lot of millions and millions of people that live on the coastline, and as that water creeps up, you can try to keep it back, but we see very often when it fails, then it can be a complete disaster. You know, if you build levees and dams and that kind of stuff too. So just worldwide, if people have to start moving away from the coast, not only are they going to be leaving the places they were, but then we have a lot more people moving into new areas, which can also be very chaotic. Just as an example, imagine if 50,000 people moved into, you know, our neighborhood here or our area around here too, right? It's like, okay, well, where is everyone going to live, and are they going to compete for jobs and all of that as well? Okay, so again, 8, explain how atmospheric warming might affect each of the following. Glaciers, sea ice and polar ice caps predicted to not only melt, but melt even faster. Okay, sea levels in coastal areas, right? The major reason why sea levels are rising is because water, as it gets warmer, it expands, okay? So thermal expansion is actually the biggest reason. So as our seas get warmer, we see them expanding, and that actually then rises up and we can have coastal flooding. And also, yes, when ice that is on land melts and runs off into the water, that also then can make it rise as well. But the biggest reason is warmer water just expands and takes up more space, okay? Ocean currents, ocean water temperatures, right? Same sort of thing, right? When water releases its heat, it then becomes cooler and sinks down. We have this conveyor belt that, you know, flows in our oceans, and it moves warm water around and cold water around. Well, when the water gets warmer, its potential, as one potential would be, as ironically as it melts the ice, as that then fresh water flows in, that can actually disrupt that conveyor belt, which could actually make it colder in Europe. You have the stop of that conveyor belt bringing warm water to Europe potentially, right? Which would then make it colder up there because it's much more to the north. And because that water is not flowing, then it can continue to get warmer and warmer in the tropics. All right, and again, precipitation and weather, it's one of those things that it's just very unpredictable. Some places we'd expect to have more precipitation and some places less. And again, as I just said, you want the right amount of water. You know, species have adapted to certain range of tolerance, and we don't want to go further one way or another with that. All right, 9, the Kyoto Protocol. So Kyoto was an international treaty, right? Countries from all the world got together and agreed that we need to do something about global climate change, and we need to reduce the amount of carbon dioxide being released, you know, methane and nitrous oxide. And that was the goal, to get everyone sort of on board to try to do their part. You know, part of the United States, we decided to not, you know, to take a part of it. We felt that it potentially could be harmful to economic growth, and also we felt that some countries weren't being held to the same standard, and so for that reason we did not want to be involved with it. But again, you know, you don't necessarily have to be in an agreement to also then say, listen, we're going to do these things anyway. And so we've seen many states and, you know, cities say, listen, we want to do our part. And we see businesses do this too. They say, we want to be, you know, good to the environment and also good for business, and we want to do what we can. Okay. All right, 10. Why is having ozone, right, in the stratosphere important? Because again, it filters out the harmful ultraviolet radiation. And we're talking up in the stratosphere, right? And when we produced things called chlorofluorocarbons, or CFCs, this chemical would go up into the ozone layer and actually turn the O3 into O2. O2 does not you know, filter out the UV rays. And so we were seeing that, you know, scientists were studying this, and realizing, oh my gosh, what's going on with the ozone layer? It's critically important. We figured it out that it was the CFCs doing this. And so we essentially stopped using them. And that's a great, positive sign that shows that when we listen to the science, we can make good decisions to protect our planet and other species that are here. So again, for 10, the ozone up in the stratosphere, it filters out that harmful ultraviolet radiation. So 11, list the effects of ozone depletion of the following: human health, wildlife, and even we can kind of answer all this together, right? So you have this very high intensity ultraviolet radiation. So human health, it can burn skin. It can cause problems with the eyes, right? Cataracts, things like that. Now, okay, but we can wear sunglasses, right? That have UV protection. We can put sunscreen on. What about sea? What about the wildlife, right? They can't do that. Or trees and that kind of stuff. When this higher radiation is hitting plants and wildlife, it can obviously cause problems potentially with them, and also potentially reduce the amount of food that's being produced. All right, 12, the Montreal Protocol and Copenhagen Protocol both centered around the reduction of chlorofluorocarbons, right? And any chemical that would harm the ozone layer. All right, so that's what that is. Remember, these are international agreements. This idea that these countries say, they get together in Montreal and Copenhagen, and they listen to the data, the science, and they say, you know what, this makes sense, And I'm going to kind of answer 13 here too at the same time. So 12 was they're focused on reducing any chemical like chlorofluorocarbons that would harm the ozone layer, and countries agreed, hey, listen, this is a problem. Let's use substitutes. Let's stop using the CFCs. And and it's worked. That's the great positive sign, which brings us to 13. How can the lessons learned about the success of Montreal and Copenhagen can be used to help with reducing greenhouse gases? So again, the idea is the country sent delegates to listen to the scientists, and the scientists said, listen, here's what's happening to our ozone layer. Here's what's causing it, and this is what we can do. And essentially the country said, yeah, that makes sense. We need to stop using these chemicals, and because we've got to protect our ozone layer, it's in all of our best interests to do this. And so they did. And so the lesson with this that is so positive, that if we can do this with the ozone layer, right, and it is in the process of healing itself, we can do it with other environmental problems too. Always remember that. I don't care if it's climate change or any other things. If we listen to the science and we realize we're all in this together and it is in our best interest to take the right and proper actions, then we can solve any environmental problems that come our way. But we have to make sure we're taking action and not just, I guess, wishing that things would go away or things would be different. Okay, so that's that.